Hello everyone, I'm Anil and today we will start our chapter solution topic solubility of gas into liquids. First we will start our definition solubility. Definition of solubility means at fixed temperature the maximum volume of gas in centimeter cube, which is measured at STP, standard temperature pressure, that may be dissolved in a 6 volume of solvent to form saturated solution. Means at a particular temperature the maximum volume of a gas that may be dissolved in a solvent to form its saturated solution is called solubility. Now take one example. Oxygen dissolved in water and another helium in water. Then what we say that oxygen is more soluble in water as compared to helium. It means that if we have two containers and each have equal volume of water, in this beaker we dissolve oxygen and in this beaker we dissolve helium. So if the volume of both containers are same, then in this container the amount of oxygen will be more as compared to helium, because solubility of oxygen is more in water than helium. If we take some other gases like CO2, same volume CO2 in water, or argon in water. So why these gases have different value of solubility in water, we will discuss here factors which are responsible for the solubility of gas into liquids. Our first point is nature of gas. So gas which chemically react with solvent is more soluble means if we have two gas, first is NH3 ammonia and second is oxygen. When ammonia dissolved in water, it forms a compound that is ammonium hydroxide. And when oxygen dissolved with water, it does not form any compound. So from this we can say that solubility of ammonia is higher in water as compared to oxygen. Now, second point, tendency to liquefy means the gas have higher critical temperature is more soluble. Means critical temperature means the temperature above which a gas cannot be liquefied, however any amount of pressure applied on it. So if we have hydrogen which have critical temperature 33 Kelvin and SO2 which critical temperature is 43 Kelvin, so we can say that SO2 is easily liquefied as compared to hydrogen. So SO2 is more soluble as compared to hydrogen. Got it? Now, second point is effect of temperature. Now, when gas dissolve with liquid and form solution, they release some amount of energy, means the process is exothermic, and from Le Chatelier principle we know that for exothermic reaction, when the temperature increase, equilibrium shift toward the direction of reactant. So we can say that as the temperature increase, the solubility of gas decrease in liquid. Means as temperature increase, solubility of gas decrease. From this, we have one question for our board exam, that why aquatic species feel more comfortable in cold water. So, we know during the summer time, as the temperature of water increase, the solubility of gas decrease, means amount of oxygen in water decrease. So, aquatic species will not receive that amount of oxygen for their breathing system. Okay? And now, when we plot a graph between temperature, temperature in degree centigrade and solubility, as the temperature increase, the solubility of gas also decrease. So we get here a curve downward. Okay? Third point is effect of pressure. Effect of pressure. We know that gases are compressible in nature, so solubility of gas is highly affected by pressure, and this effect is firstly studied by Sir Henry. He told that mass of any gas dissolved in a liquid at a particular temperature is directly proportional to its equilibrium pressure in the solution. Finally, N equal to K multiplied by P, where K is a proportional constant. This effect is also studied by Dalton. He also gave a relation in terms of mole fraction. Means mole fraction of a gas is directly proportional to its partial pressure. And finally, where 1 upon K dash equal to Kh, and Kh is Henry constant. Okay, so from that, pressure equal to Henry constant multiplied by mole fraction. When we plot a graph between mole fraction of a gas and equilibrium pressure, as pressure increase, mole fraction of gas also increase. From this we gain a value, we gain a relation inclined at this angle, and this is equal to Henry constant. So Henry constant for particular gas may be calculated by this relation. Finally, Henry law may be defined: partial pressure of a gas is directly proportional to its mole fraction. Now, from Henry law, partial pressure equal to Henry constant multiplied by mole fraction. Now, we will study about the characteristics of Henry constant. So, first point is that different gases have different value of Henry constant, and this value depend upon nature of gas, comma, temperature. Means value of Henry constant for a particular gas depend upon nature of gas and the temperature we use. Second point, higher the value of Henry constant, less soluble of a gas. For this, we have two gas, first is hydrogen and second is carbon dioxide. The value of KH for hydrogen in water is 71.18 bar and for CO2 it is 1.67 bar. From this we can say that the value of KH for hydrogen is higher, so the solubility of CO2 is more compared to hydrogen in water from this relation. Finally, third point, higher the temperature, value of KH also high. Means as the temperature increase, the value of KH also increase. So from this we can also say that as the temperature increase, the value of KH also increase and the mole fraction or means solubility of gas also decrease. Next, limitation of Henry law. Of so first limitation, pressure should be low, because at high pressure the KH value disturbs. When temperature should be high, because at low temperature also the value of KH disturbs. Third point is should not chemically react with solvent. Means if we have NH3 ammonia which dissolve with water, it forms a compound NH4OH. So this law is not applicable for ammonia. Next, gas should not dissociate. Means when HCl add with water, it gives hydronium ion and chloride ion. So these are the four limitations of Henry law. Pressure should be low, temperature should be high, gas should not be chemically react with solvent, and finally gas should not dissociate in solvent. Application. So, first application of Henry law is in production of carbonate beverage. Means cold drink bottle, CO2 gas mixed with the drink, and the cap. We know the pressure inside the bottle is high, than outside. So at high pressure, CO2 mixed with drain, and when we open the cap, pressure becomes equal to outside pressure. And as the pressure decreases, CO2 comes out in form of bubbles. Next application in deep sea diving or scuba diving. As you know that a person goes into the sea, we know that pressure downward is high than surface. So nitrogen mixed with oxygen dissolve more rapidly in the blood, and when the person comes out as a result of decrease in pressure, nitrogen comes out, and in capillary tubes it forms bubble and prevent the passage of oxygen gas, which is very painful and may be cause death. So nowadays the cylinder filled with oxygen and nitrogen with helium gas, because size of helium is small and it is less soluble. Next application at high altitude. We know that pressure at high altitude is lower than ground level. So the solubility of oxygen in blood decrease, and a person at high altitude feel weakness and unable to think. This problem is called anoxia. So these are the three applications of Henry law. First, production of beverage. Second, in deep sea diving, and third, at high altitude. Finally, hope we will meet soon